Good afternoon, everyone. My name is Nkole Mlinga, and presenting with me is Richard Mufuzi, Geoffrey Ngoma, and Fraser Nyambe on the topic Rule-Based Automatic Generation of Electronic Thesis and Dissertations Metadata. Our supervisor for this project is Dr. Lydon Piri. Since the year 2010, the University of Zambia has been ingesting electronic thesis and dissertations into the UNZA repository. However, the quality of ETDs ingested has been poor. This is as a result of human-related factors that are involved when these ETDs are being uploaded on the repository. Therefore, our research was about the rule-based automatic generation of missing metadata elements from the uploaded documents or records on the repository. This is just an image which is showing the University of Zambia Research Repository. The problem statement. These uploaded ETDs that are on the UNZA repository are mostly used for research purposes. However, people find it difficult to use these repositories due to the poor quality that is attached to the ETD metadata elements. Therefore, the development of a rule-based technique with Spaces software library to automatically generate the missing metadata elements will be able to improve the metadata quality of the records. Our research questions for the project. The first one is, what common missing ETD metadata elements are to be identified in the PDF manuscript? Number two, which part of the ETD PDF manuscripts contains the metadata? The last one, how is the design and implementation of software tools useful in the extraction of metadata from PDF manuscripts? My colleague will pick it up from here.
Presenting on related works as well as the methodology, this is Richard Mfozi. This section is about literature work previously done by other researchers as well as their similarities and differences in line with the objectives for this research. The table just shows the differences and similarities. So objective number one, related work number one, the similarity was spelling variation while the difference was name specification. Related work number two, the similarity was metadata quality in repositories, while the difference was machine learning. Objective number two, the related work number one, the similarity was use of controlled vocabularies, while the difference was in implementation of multi-level subject classification module. Related work number two, similarity was structured data, while the difference was machine learning. And objective number three, related work number one, similarity was manipulation of PDF content, while the difference was manipulation of HTML content. Related work number two, similarity was use of vocabulary sets, while the difference was in the integration of repositories with subject-controlled vocabulary. Methodology. Um, the following steps and procedures were conducted for each objective. Objective number one, metadata harvesting from the UNZA repository was conducted using the OAI PMH protocol, which downloads XML files, as well as the OAI ORE protocol, which downloads PDF files. The second step, data manipulation was conducted using OpenRefine, and the data analysis was conducted using Excel. And in the third step, a cross-match between the UNZA repository and OpenUCT repository was done based on the ETDMS. Objective number two involves two steps. Step one, document analysis of DRGS guidelines on how postgraduate students format their essay dissertation. Step number two involved randomly sampling 60 ETDs from the UNZA repository so as to identify the sections with metadata elements. This is just an image showing DRGS guidelines on the UNZA repository. Objective number three, step one, we created a dataset for the 4,149 PDF files. Step two involved the extraction of acknowledgement section from the PDF manuscripts using PyPDF2. Step three involved extracting the contributor's detail or supervisor details from the acknowledgement section using Spacey and a Python script for basic string matching to extract the supervisor details. This marks the end of the methodology section. The next presenter will present on results and discussions.
To continue on the results and discussion, my name is Fraser Nyambe. So the results on objective number one, based on the data analysis on the UNZA repository. 4 metadata elements were totally missing from the UNZA repository, and 11 doubling core elements were inconsistently associated with the metadata ETDs. Comparative analysis showed that the OpenUCT had 13 missing metadata elements and UNZA repository had 24 missing metadata elements, conclusively saying that the exemplary record had fewer missing metadata elements as compared to the UNZA repository. Then the table shows the missing metadata elements on the UNZA repository. Then this is a graphical representation of the missing metadata elements on the UNZA repository, where we could probably see that contributor, source, coverage, and rights are totally missing from the UNZA repository, and the inconsistency in the association from metadata elements to the ETDs. And this is a picture for UNZA repository as well as Open UCT repository. Then objective number 2 results showed that no, the preliminary pages contain the supervisor's details according to the DRGS postgraduate regulations, as well as this random sampling of 60 records from the UNZA repository showed that the approval as well as the acknowledgement section contain the supervisor's details, but most likely on the acknowledgement page. Then this is a picture of the approval of the certificate of approval as well as the acknowledgement section that has supervisor's details. Then objective number 2 results made use of the PyPDF tool for extraction and manipulation of text extracted from the PDFs, as well as the use of SPACY with its inbuilt named entities recognition capabilities to extract the supervisor's details. And this is an example of a record named entities extracted by SPACY. Then the system evaluation. To evaluate the system, we had to come up with a data set for the ground truth generated from the transcription that was done manually by the individuals that were assigned by the UNZA. Then a matrix, an evaluation matrix was used, which is particularly blue, the bilingual evaluation understudy, to estimate the accuracy of our system. Blue was used because it's precision based as well as its scores are based on likeness generated from the results as well as in comparison with the ground truth. Then this is the scores for the metadata elements extracted from the UNZA repository. This is a comparative analysis between the automated generation and as well as the ground truth with the particular blue scores. Then the graph shows the distribution of the scores, and from the graph we can clearly see that to prove the accuracy of our system, most of the scores are arranged on between 0.50 to 1.25, manually interpreting to say that no, our system is accurate enough because most of the scores are related to the standard deviation. Confirming the accuracy, we have the histogram with the blue scores. And just a quick interpretation of the scores, we would say that blue scores range from 0 to 1, where 0 represents 0% likeness, as well as 1 representing 100% likeness to the compared values. The closer to 1, the more accurate the evaluation, and closer to 0, the inaccuracy of the evaluation. From the blue scores, we clearly see that the system is accurate. This is because the values for the blue scores are clustered around the central region of the curve. And my colleague will conclude.
Taking it off from where my colleague left, my name is Geoffrey Ngoma, and I'm concluding the project. The automatic generation of ETDs plays an important role in the searching of the records or publication by multiple researchers. The relevance of this research is the automatic retrieval of research metadata from repositories and high-quality metadata harvesting from research output. And the findings of the research are: the first is the UNZA repository only has 11 inconsistent associated metadata elements and 4 other metadata elements are totally missing. The second is the supervisor details are located on the acknowledgements section of the manuscript. And the last, the use of a rule-based approach, which made use of software library like SPACY. And this marks the end of our presentation.